This is the video lesson for Algebra 1, 8.7, Factoring Special Cases. So here, just like when we multiplied and there were special cases to memorize, you can also factor. So we'd be going backwards. So we'd be starting with this and going backwards. So this is just a shortcut. You can memorize this if you want. If you notice, hopefully by the end, you'll be able to do this shortcut on your own. It's much quicker than the method we use, but I just teach it with the same method so that you only just learn one method. And then if you find that your shortcuts are easier and you want to use them and you memorize, that's fine. But I'll show you how these work without learning anything new. We'll just keep doing it the same way we've been doing it. So this first example here, we're just going to start by, remember we're going to have to split out this negative 12x into 2. And then we're going to do our diamond. Remember, this is invisible 1. 1 times 36 is just 36 on top. And then negative 12 they have to add to. So if we just went through our factors of 36, 1, 36, 2, 18, 3, 9. They both have to be negative to add up to a negative number and multiply to a positive number. 9, 10, 11, 12. 3 times 9 is not 36, sorry. There we go, sorry. 3 and 12 does not add up to 12. And then 4 and 8 does not add up to negative 12. Yes, it does. That's because I'm not picking the right numbers, sorry. 4 and 9, here we go. That does not add to 12, and then does not go into 5, and then negative 6 times negative 6. So that's where we're going to get 12. So these special cases are, what makes this a special case is that these two numbers are the same. But you don't need to know that. You don't need to look at this and recognize that. You can just go about doing it the same way you always do it. They just happen to end up being the same numbers. So when you split out your negative 12, it becomes negative 6x, negative 6x. And then you undistribute the first two by pulling out the GCF, which is x minus 6. And then the GCF here is negative 6, x minus 6. And then look what happens, x minus 6 times x minus 6. So the factors just end up being the same. So you can take the extra step to write x minus 6 squared. That's how I like to see the answer. If you leave it like this, that is also right. That's fine too. So that's all. It's just the same exact thing we've been doing. It just happens that there's a shortcut. Maybe you notice that the two numbers are the same that multiply, like 36 is a perfect square, and they the square root of that is 6, and you can double negative 6 to get 12, and then you can just jump from here to here if you memorize it, but otherwise just go through the same. Okay, so try this on your own. If you do want to try the shortcut, go ahead, or just do it the way that I taught it for all the ways. Okay, press pause to check your solution. Okay, hopefully you got x plus 3 squared. And that if you did the shortcut, you would have noticed that 9 is a perfect square, and 3 times 3 is 9, so that would be 3, and 3 plus 3 is 6, so that means just factors to x plus 3. Or you look for two numbers that multiply to 9 and add to 6, right, because 9 times 1 is 9. 6 goes here, it's 3 and 3, split it out, and then undistribute. Okay, so let's move on to another one. I'll show you this with the shortcut, just if you want to see one with the shortcut. Let's look up here. So we can see that this, what I notice about this is because you'll be doing these when they're all mixed up. They're not always going to be under the special case grouping, right? But we do notice that this is a perfect square here, right? So the square root of 49 is 7. So if you notice that, and you can see, oh, 7 plus 7 is 14. So this means this is going to split into negative 7x minus 7x plus 49. Right, the shortcut is just x minus 7 squared is going to be the answer. Okay, because once you have this 7, and since this is negative, then this is negative. And that's, if you look up to the shortcut here, right, it's this one here. Right, this is negative, this is 7 squared, so b is my 7, a is 1 squared, so a is 1, and so it would just be 1a, or 1x in our case, and then minus 7. So, and you can just, as you just practice with these, you'll notice shortcuts, but if not, if you don't like shortcuts, you just like to know one way to do it, pull out the GCF, x minus 7, pull out the GCF here, again, make this one positive, so you're going to pull out the negative 7, which makes this a minus 7, and then this just becomes x minus 7 times x minus 7, which is just squared. Okay. So try this next one. Well, no, I'll do this one, then you can try the next one, because now the a isn't 1. Okay, so here, remember the first thing we look for is the GCF. 4 is 2 and 2, 20 is 2, 10, 2 and 5, and 25 is 5 and 5. So they don't have anything in common, so there isn't a GCF. But just always remember to look for that. It'll make your life easier if you can find it. So we'll do our diamond. This is going to be 4 times 25, which is 100. So we're looking for 2 numbers that multiply to 100 and add to 20. With these, if you, sometimes you can start backwards. I know I always start with 1, right? We do 1 and 100, 2 and 50, 3, 4, 4 and 25, 6, 7, 8. 8 goes into 100, right? No, it doesn't actually. And then 9 doesn't, 10 does, right? So it's 10 and 10. And maybe you just saw that right away. Sometimes these are easy because you could just, when you see 100, you think of 10 and 10, and you can easily see it's 20, so you don't have to write those all out. But that means this gets split 4x squared plus 10x plus 10x plus 25. And then these two have a GCF of 2x. So 2x plus 5. And then this is a 5. And then 2x plus 5. All right, so this is 2x plus 5 times 2x plus 5, which is 2x plus 5 squared. Okay, and then the shortcut here would be noticing that this is a perfect square, and that's a 2. And this is a perfect square, and that's a 5. And then 5 times 2 is 10. And then 2 times 10 is 20. It's a lot of extra work. But if you notice it, that's fine. Then once you get that 2, you put it there. Once you get that 5, you get it there, and you see the positive, and then you square it. If you notice that pattern, you can go and do your shortcut. But it's just as easy to do this and just learn one way rather than trying to memorize shortcuts. Okay, so try this one on your own. Press pause, and then check back for the solution. Okay, hopefully you got 4m minus 9 squared. And then here, right, when you did the 16 times the 81, you got 1296, which is a huge number. So sometimes when you get a big number, remember, instead of, I usually go through the factors, 1, then 2, then 3. But sometimes with big numbers, if you just take the square root, that will take you to the end. The last two, if you go in order of factors, 1, 2, 3, you get to the end, it's going to be 2 numbers that are close to each other. They're closest 2 factors that equal that. And you can find where that's going to be around if you take the square root. So in this case, I took the square root of 1296 and I found 36. So I knew 36 was a factor, and 36 times 36 equals 1296. And then I just added them together and I got 72. So I knew that those were the answers. So that was a little shortcut there. Sometimes it helps to just take the square root. And even if it's not perfect, it kind of gives you an idea of another place to start with factors. So then once that was 36, I split the 72 and negative 72 into negative 36, and then did my undistributing, and then ended up with 4m minus 9 squared. Okay. All right, so number 6, this is one where you might want to do the shortcut. The shortcut is it's a squared minus b squared. And that's when the 2 terms in the middle are going to cancel each other out, right, because they equal 0. So then this becomes a minus b times a plus b. So if you notice here, right, this coefficient is 1, the square root of 1 is 1, that's a perfect square. Here, this is 64, the square root of 64 is 8. Sorry, this is 8x squared. The square root of that is 1x. The square root of that is 8. That means this is just 1x minus 8 times 1x plus 8. X minus 8 times x plus 8. Okay, so if you notice that perfect square, you can do this shortcut. Otherwise, just do it the same way we've been doing it. You just have to be a little bit careful when you do the diamond, right? This is my c. This is actually the same as like x squared plus 0x minus 64. So when you do this, this is going to be negative 64 times 1, which is negative 64 on top. But then they have to add to 0, right? Because these 2 middle terms have to cancel to be 0. So one's going to be negative and one's going to be positive. And then for this, if you're ever doing the diamond for this and you get a 0 here, this is always going to be the square root of this number, not when it's negative though, because it has to be the same to cancel out. These two have to be the same. One's a negative, one's a positive, but they have to be the same magnitude. So the square root of 64 is 8. So this is going to be plus 8 minus 8. So then you would rewrite this as x squared minus 8x plus 8x, minus 64. Right? And you can see if you were multiplying this out, these would then cancel and you'd end up with that, right? So that's why that 0 turns into minus 8 plus 8. And then you can continue undistributing. And then pull out your 8x minus 8. Then those two match, x minus 8, and then you're left with an x plus 8. Okay? So you either have to remember that it's 0 on the bottom and just take the square root of that number, or whatever, the square root of this number when it's not negative, and then do it here, or you can do the shortcut. Okay, so try number 7, either with the shortcut or with the method that we've always been using. Press pause and then check back for the solution. Okay, hopefully you got v plus 10, v minus 10, right? Negative 100 times 1 is negative 100, that goes on top. Remember, this is the same as v squared plus 0v minus 100. So 0 on the bottom, the two numbers that are the same, or the square root of 100 is 10, so minus 10 plus 10. So split it out and then do your undistributing, and then you get v plus 10, v minus 10. Okay, and if you did do the shortcut right, you can see the square root of this is v, so that goes here. The square root of this is, the square root of this is 10. So those go both there, and one gets a plus and one gets a minus. Okay, so if we did this with a shortcut, number 8, right? The square root of s squared is s. So this would be s and this would be s in our answer. The square root of 16 is 4. So this would be 4 and this would be 4, and one gets a plus and one gets a minus. So that's a shortcut there. Okay, so number 9, we can see this is a perfect square, and this is a minus, and this is a perfect square. So we can use our shortcut. The square root of 16x squared. So we know our answer is going to be like this. 16x squared is 4x, so this gets a 4x, this gets a 4x. Square root of 81 is 9, so this gets a 9, and this gets a 9, plus, minus. Okay. If you did the long way, you'd have to do 16 times 81 equals 1296, and then it has to add to 0. So that means you take the square root of 1296, which I think we already did, and we got 36. This is 36 and 36. So one has to be positive, one has to be negative. So this becomes 16x squared plus 36x minus 36x minus 81. And then 4x plus 9 minus 9, 4x plus 9. So it's 4x plus 9 times 4x minus 9. Okay, so try the shortcut. If you're getting the right answer, go ahead and you feel comfortable with that. If you don't like the shortcut, then just keep doing it the way we've been doing it. And as you practice, you might like the shortcut later. Okay, so try number 10 on your own, and then check back for the solution. Press pause. Okay, hopefully you tried the shortcut, or if not, if you did it this way, it's probably just as easy, just not as fast. The square root of this is 5d, square root of 64 is 8, so it's 5d plus 8, 5d minus 8, and that's it. Okay, number 11, all right, just two more. Number 11 is another one. We don't notice their square roots though, perfect squares. But remember, the first thing we always have to do when we look at one of these to factor is look for a GCF. And so in this case, we have a GCF. This is 2, I think, just 2. Yeah, so if we pull out the 2, we're left with 12G, oh no, it's 6. sorry. I was going to do the whole factors, right? If we do 2, 12, 3, 4, 2, 2, and this is just 3 and 2, they both have a 3 and they both have a 2. So it's 3 times 2, which is 6. All right, that makes more sense. Pull out the 6, we get 4g squared minus 1. And so our answer is going to look like this. We can see now we have a perfect square here. The square root of that is 2g. And we can see we have a perfect square root, which is 1. So this is a 1, and then we just put our plus and our minus. And then that's our answer. Just don't forget that 6, the GCF that we took out. Okay, so try number 12. It's going to be similar. Factor out the GCF. If you're left with two perfect squares being subtracted from each other, called a difference of two squares, you can use your shortcut to find the solution. Press pause and check back. All right, hopefully you found the GCF was 12, right? Well, you can see here is a 12. You know 12 goes into that, so if you didn't have to really factor it out, but I'm showing you here, they both have a 2, they both have another 2, they both have a 3, so that's 12. Divide this by 12, you get t squared. Divide this by 12, you get -4. And then you can see here they're perfect squares, a difference of two squares. The square root of t squared is t, the square root of 4 is 2, and then plus and minus. Okay, time for practice. Enjoy.